Hello, welcome to another video. Today we are going to talk about CAP theorem. And in CAP theorem, we are going to talk about how to navigate distributed system trade-offs. So let's start. So what is CAP theorem? CAP theorem is nothing but CAP theorem. What is C? It's consistency, A for availability, and P for partition tolerance. And what CAP theorem states is that out of these three, in a truly distributed system, we can choose only two, and we need to sacrifice the other. So it presents us with a dilemma, and it's a critical trade-off in designing robust and scalable systems in choosing what two we can go for among the three. So let's talk about it in a bit more detail. Let's now talk about consistency, availability, and partition tolerance a bit more in detail. So what is consistency? All clients see the same data at the same time, regardless of which node they connect to. So let's say I have a database which has 3 replicas, and if the whole database system is consistent, no matter which database replica I connect to, I get the same result. So we can treat the whole 3 replica system of the database as a single, always correct source of truth. Then let's talk about availability. Every request receives a non-error response, even if it's not the latest data. So every request from the client in this case will be a non-error response, unless there is of course something wrong at the server side or some bug, but generally there should not be any error response due to network issue. And then the system is always up and running, ready to serve requests. And then partition tolerance. The system continues to operate despite network failures that split the system into multiple isolated subnetworks. So what is this? So let's say, again going back to the previous example, there are 3 replicas of the same database. So there is some communication in between the database replicas so that they are in sync with each other. Now what happens if there is a network failure? In case of a network failure, the nodes cannot communicate among each other, and the data of them will be inconsistent among each other. So the partition tolerance is something that says that the whole system will continue to operate even though the database replicas or the subsystems inside a bigger system goes into partition failure, but the replicas can continue to operate independently. So this is very crucial. This is unavoidable in any true distributed system, because as you can imagine, in distributed system, everything talks to each other over network, and the partition tolerance is a non-negotiable trait that we want to have. Because we stated that partition tolerance is a non-negotiable property of the distributed system, so what we need to do is, we of course need to keep P, but according to CAP theorem, we can choose either between C or A. So the system can be either CP or AP. So what is a CP system? CP is a distributed system that offers both consistency and partition tolerance. So it prioritizes consistency. If a partition occurs, then the system will sacrifice availability to ensure all data remains consistent. So going back to the previous database example, I have 3 replicas, and in case there is a communication break between the partitions, between the replicas, then we will focus on consistency. So in that case, let's say one client needs to write something to the database. Now because there is partition tolerance, the database knows that the write can't be propagated to the other replicas. In that case, the database will reject the write request in favor of consistency. So the database will make sure that whatever read request the client send it, all the read requests send the correct data response. So to send back the correct data response in case of a partition fault, the database system needs to completely stop accepting write requests. What are the use cases? In case of banking transactions, systems where data integrity is very paramount. For example, let's say I have deposited $100 to my account, and no matter which database replica I connect to, I need to see the deposited amount reflected in my bank account. So in that case, the write propagation is very necessary. If I connect to one replica, I see that $100 bank balance, and if I connect to another replica, I see $0 bank balance, then it's a very confusing user experience and somewhat alarming as well. So that's why the banking systems need to prefer consistency over availability. On the opposite side, there is availability plus partition tolerance systems. So it prioritizes availability. The system remains available during a partition, but data across nodes might be temporarily become inconsistent. So in this case, the write will be accepted even though the data is not propagated. And when the customer or a client sends a read request, then it will get the data back. The read will always succeed, but depending on which replica it connects to, the data can be different. So what are the use cases in this case? Let's say social media feeds, e-commerce product catalogs, where the data can be synced eventually. In that cases, the AP is acceptable because we don't want to delay any write, because these systems operate on a very large scale and a lot of people use the systems, but the feeds are not very critical data as an example. So in this case, you can go for AP. So let's quickly talk about why CA system is not practical in case of a distributed system, at least in modern distributed systems. So in case of CA, the consistency and availability are prioritized. The combination implies a system that is always consistent and always available. But what is the catch? The catch is it gives a partition tolerance. And in case of modern distributed systems, because we are so dependent on the different components talking to each other over network, the partition tolerance is really crucial, because network is always unreliable, and it very well might be that the network between the different parts of the system can be down. In that case, shall we completely shut down the system? Of course not. The system still needs to be reliable and still needs to function and continue to operate because of SLA, SLO and other stuff. So network partitions are an inevitable reality in distributed systems, so we can't simply opt out of partition. So we should not really go for any CA system in distributed system scenario. Of course, if we have everything in a single machine, then all the processes interact with each other inside the system itself and not over network. In that case, CA system is possible, but that's not really a distributed system, right? So we always go for CP or AP systems in real world. So the P, or the partition tolerance, is non-negotiable for distributed system in the modern world, and the best choice between consistency and availability, that depends entirely on application specific requirements and tolerance for data staleness versus downtime. So as we discussed in earlier examples, the consistency is more required where the data is very critical. The consistency is very critical, for example, in financial sector, whereas the availability can be given preference in case of social media, where data is not that critical. Many modern systems implement eventual consistency with strategies for conflict resolution, offering a spectrum rather than a strict CPAP. This is a very important point which we can talk about maybe in a future video. But most of the modern systems, they offer eventual consistency. And what eventual consistency means is that even though the system is available and it gives preference to availability over consistency, in case of a partition tolerance, whenever the network issue gets resolved, the data will be synced, and there is a guarantee that all the data will be eventually consistent over all the replicas of databases. For example, modern databases like MongoDB, they offer eventual consistency. But there is a catch in eventual consistency. Generally, there is no guarantee when actually the data will be consistent. It can be just a second or it can be a year, at least theoretically, but there is no guarantee over the time frame. So understanding CAP theorem, it allows us to make informed decisions about data stores and system behavior during failures. It forces us to think about the priorities that we need to focus on while designing a distributed system and where to focus. So yeah, that's it for CAP theorem for now. Hopefully you like the video. If you like the video, please hit the like button and subscribe to my channel and share the content. Thanks for watching the video. See you in the next one.